Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module that is the today's topic that is the procedural programming topic. That is how to do the procedural programming or how what is the procedural programming, what are the content that is available in the procedural programming. And we have covered in the last class we have covered chapter number 20, that is not 20, that is chapter number 19, that is how to do the interaction with the hardware, that is interaction with the hardware, that is how we can interact with the hardware. Now I'm going to continue with the same topic, with the continued topic, with the extended topic or the next topic. So let's start with the session with the previous topic what we have covered in the last class, because in the last class I think there are some miscommunication about the meeting ID. There is miscommunication with the Larry. So how to communicate with the keyboard, that is the first part, or that is the first one. So let's start with the previous session, that is how to communicate with the keyboard. So in the last to last class we have discussed how to communicate with the storage devices like magnetic disk, magnetic tape, optical disk. Now in the next class we have discussed how to communicate with the keyboard, that is how to communicate with the keyboard, what are the tools available, what are the macros available, what are the functions available, what are the applications available, that is how to do the communication with the keyboard. So like mouse messages, there also exist messages for keyboard. So like mouse messages exist, there also exist messages for keyboard that are known as the keyboard messages. The keyboard messages includes the WM key down, WM key up, WM cat. Out of this, key down and the key up are sent to an application. So these are the two messages that is available that are sent to an application, which has the input focus whenever the key is processed and whenever the key is pressed and released respectively. So whenever we press the key, there are two functions that is used, that is the WM key down and the WM key up. The additional information in case of these messages is the code of the key being pressed or released. So the additional information that is given over here, that is a code of the key that is given or that is pressed or released. When we tackle WM key down or WM key up, we need to then ourselves check the status of the toggle keys like num lock and the caps lock and the shift key like control. The shift keys are used, that is the shift key, control key, and how they are executing like this one. If we wish to avoid all this checking, we can tackle the WM char message instead. So we are tackling the message that is a WM char message. What is mentioned above is the normal procedure followed by the most Windows application. So what is mentioned is totally different, is a normal procedure that is available, that is followed by most Windows applications, that is used by most Windows applications. However, if we wish to do or if we wish to go a step further and deal with the keyboard, that is how to deal with the keyboard, we need to tackle it differently. That is whenever there is a keyboard, whenever there is a multiple keys that is available, we need to tackle it in a different way. For example, we are to perform one of the following jobs. What are the jobs that is available? This is the example. First example or first point says once you hit any key, caps lock should become on. So this is one of the operation that is performed. So once you hit a key, once you hit any key, then caps lock should become on. Once it becomes on, it should remain permanently on. So first of all, you press a hit key, then caps lock is on, or the caps lock should become on. Once it becomes on, it should remain permanently on. That is, it remains permanently on. The next one is if you press a key once, it should appear twice on the screen. This is again the one of the scenario, one of the tasks that is provided. The next task is if you hit up key A, then the B should appear on the screen. If you press a B, then C should occur, and so on. That is one above or the one further character is placed whenever we place any character. If A, then B, if B, then C. Right. Note that all these effects should work on a system-wide basis for all Windows 32 applications. To be able to achieve these effects, we need to understand two important mechanisms. So whenever we deal with the Windows 32 application, we are dealing with, or we are considering the two important mechanisms. One is the dynamic linking and one is the Windows hooks. Let us understand these mechanisms one by one. First one is your dynamic linking. This is, as we saw in chapter number 16, Windows permits linking of libraries stored in a DLL file. So as we saw in the chapter number 16, that is every application, every linking libraries is stored in a file, that is a .dll file during the execution. DLL file is a binary file that cannot execute on its own. So there is a DLL file that cannot execute on its own. Rather, it contains a function that can be shared between several applications running in a memory. Or rather, it contains various functions that is shared between several applications that is running in the memory, that is running in various memories. Next topic is your window hooks. That is, what are the window hooks, or what is a window hook, how it can be achieved. As the name advises, the hook mechanism permits us to intercept and alter the flow of messages in the operating system before they reach the application. So as the name advises, the hook mechanism permits us, or it allows us to intercept and alter the flow of messages in the operating system before they reach to the application. Since hooks are used to alter the messaging mechanism on a system-wide basis, the code for hooking has to be written in a DLL. That is a code that is given, that is available in a, or that is a code is available for hooking that is written in a DLL. The hooking mechanism involves writing a hook procedure in a DLL file. That is a hooking mechanism that is available, and registering this procedure with the operating system. That is, what is the hook procedure? If the question arises, that is writing a hook procedure in a DLL file and registering this procedure with the operating system. Since the DLL cannot execute on its own, so we need a separate program that would load and executes the DLL. That is, since there is no way, or the DLL could not execute on its own, so we need a separate mechanism, we need a different mechanism that would load and executes the DLL, that is a dynamic linking libraries. This is window hooks. For different messages, there are different types of hooks. If there are different messages, there are different types of hooks that is available. For example, for keyboard messages, there is a keyboard hook. For mouse messages, there is a mouse hook. So there are different messages, there are different hooks available. You can refer MSDN for nearly a dozen more types of hooks. Here we would restrict our discussion only to the keyboard hook. That is, we simply uses the mechanism, we simply restrict our discussion to the keyboard hook. Before we proceed to write our own hook procedure, let us understand the normal working of the keyboard message. That is, this is the normal working, how keyboard works. First of all, there is a keyboard. With the help of keyboard, there is an interrupt. That is, an interrupt occurs. Then there is a kernel routine. Then there is a device driver ISR. So if there is a kernel routine, there is a device driver ISR. Then with the use of device driver ISR, that obtains the key code by interacting with the KB controller, that is a keyboard controller, that is again given to the keyboard. So whenever a hit is pressed, there is an interrupt from the keyboard, and whenever there is a kernel routine, then there is a device driver ISR. Right. Then obtain the key code for interacting, or by interacting with the KB controller. Then after using the device driver, that is like a mediator that is provided by the ISR, or that is interrupt service routine, then places the key code in a system messaging queue by calling the keyboard event. So first of all, there is an interrupt, then there is a kernel routine, that is a kernel procedure, then there is a device driver ISR, that places the key code in a system message queue by using the function that is a keyboard event function. Then there are a system message queue, that means maintaining a queue one after the another. There are 4 queues, or 4 or 5 queues, and then there is a operating system, that means operating system is used, that is a part of the queue. Then it divide, or operating system divide into various application, that is for which application the queue is maintained, that is application 1, application 2. This is application 1 message queue, application 2 message queue. This is application 1, this is application 2. So with reference to figure 19.7, here is a list of steps that are carried out when we press a key from the keyboard. So whenever a key is pressed from the keyboard, what are the list of steps that is carried out? On pressing a key, an interrupt occurs and the corresponding kernel routine gets called. So whenever we press a key, an interrupt occurs. And the corresponding kernel routine gets called. Right. Next point says the kernel routine calls the ISR of the keyboard device driver. Then ISR communicate with the keyboard controller, that is the ISR interrupt service routine communicate with the keyboard controller and obtains the key of code of the key pressed. That obtains the key or obtains the code of the key pressed that is available. Then ISR calls a operating system function, that is a keyboard event function, to post the key code to the system message queue. That is operating system calls a OS function, that is operating system function, that is known as the keyboard event function, to post the key code to the system message queue. Then at last the operating system retrieves the message from the system message queue and posts the message to the various application with regard to which the keyboard key has pressed. So this is the explanation of this program. This is the step. First of all, there is an interrupt, there is a kernel routine, device driver places into the system message queue. So it is available to the operating system. So it is a responsibility of the OS to divide these queues into various applications like application 1 and application 2. So this is the same scenario that is used. On pressing a key, interrupt occur. Then the kernel routine calls the ISR, then communicate with the keyboard controller, then uses a function that is a keyboard event function. Then operating system retrieves the messages from the system message queue and posts to the message queue of the application for which they have been pressed. Now let us now see what needs to be done if we have to alter this procedure. We simply need to register our hook procedure with the operating system. As a result, our hook procedure would receive the messages before it is dispatched to the appropriate message queue. That is, first of all, we have to register with the hook procedure that is available with the operating system. Since our hook procedure gets a first shot at the message, it can now alter the working in the following 3 ways. What are the 3 ways how it can be done, how we can alter the, or how we can alter the working, alter the iteration? What are the 3 ways? First of all, it can suppress the message altogether. That is, it can uses the message altogether. Then it can change the message. Then it can post more messages into the system message queue using the keyboard event function. So these are the 3 scenarios that is used. First of all, it can suppress the message altogether. Then it can change the message. Then it can post more messages into the system message queue, that is using the keyboard event function. Let us now put all this theory into the practice by writing some programs. So let us first of all the caps lock permanently on. That is the first part. That is the how to do the how to write a program. What is the program? That is how to make the caps lock key already or remains the on. That is the caps locked permanently on. Let us now write a program that keeps the caps lock permanently on. This effect would come into the being when the first key is hit subsequent to the execution of our program. In fact, there would be two programs. That is, there are two programs that is available. The first program is a DLL containing a hook procedure that achieves the caps lock effect. An application exe which loads the DLL in the memory. That is the application executable which loads the DLL into the memory. Given below is the source code of the DLL program. This is the source code. How we have remains the caps lock on. So this is the program. First of all, there is a windows.h, that is the Windows header file is used. Then there is a static h hook hkb equals to null. Then handle h, that is handle is the macro that is used, and h is the variable name. Then there is a bool, that is a bool. Then std call dll main. So bool is the variable, then there is a std call, then there is a dll main, and these are the various parameters argument that is used. One is handle h module, dword, ul reason, fork call, then lp void, lp reserved. Then stores the value of h module into the h, and then there is a return true. Then the next part is bool deci spec, that is the dec ls spec. Then uses to or uses the argument as a DLL export, that is exporting the DLL. Then there is the install hook, that is installing the hook, that is registering the hook. Then uses the hkb as a variable and stores the output of the set windows hook x function, that is a wh keyboard hook procedure keyboard proc into the variable that is a hkb. Now check the condition. If it is equals to null, that is hkb equals to null, then return false, else return true. So it is equals to null, then simply return the false, and then else simply returns the true. Then this is the function of the DEC L spec. Then this is the L result, that is the result of the DEC L spec. Then this is the argument that is used, that is the DLL export std call keyboard procedure. The same procedure is used in the same of the Windows proc, that is a win proc. In the same way there is a keyboard procedure, and these are the various arguments like encode, int encode, then wparam, lparam, lparam. Then there is a short int, that is a short int is used, the variable name is state. Then check the condition. If encode is less than 0, then return call next hook x hkb encode wparam iparam. If it is less than 0, then return the function that is call next hook x hkb encode wparam iparam. Then the next part, if it is less than 0, then if it is equals to h action and d word I param and 0 into 4 0 0 0 0, then state equals to get key state. That is, the get key state is the function, and the output of get key state is stored in the state variable. Then check the condition, that is if state ampersand 1, that is the AND condition is used. If it is equals to 0, check the condition. If it is equals to off, then the keyboard event is VK capital 0, keyboard event if extended key 0. Then keyboard event VK capital 0, keyboard event extended key, keyboard event key up 0. That is the event that is available for the keyboard. Then there is a return call next hook, that is a hvk encode wparam iparam, right? Then there is a bool that is a DECL spec, DLL export, remove hook, then return, unhook, Windows hook X HKB. So these are the various functions that is used over here. Now, what are the steps? How we are able to perform the Linux programming? So these are the steps how to create the program, how to create this above program. First of all, select the file, that is go to the file, then select the new option. So first of all, go to the file option and select the new command to start a new project in the VC++. New project means a new file, a new program. Then from the project tab, that is select or go to the project tab, select Win32 dynamic link library and then click on the next button. That is the uses the project tab, that is go to the project tab, select the Win32 dynamic link library. That is the next part, that is the next step, that is the Win32 dynamic link library, and then click on the next button. Then in the Win32 link library, step 1 of 1, that is steps are available, wizard is available. Select an empty DLL project and click on the finish product or finish button. That is the empty DLL project, select on this one, then click on the finish button. Then select file new option, that is go to the select on the or click on the new option. Then from the file tab, select C++ source file and give the file name as hook.h. That is go to the file tab, select the C++ source file and give the file name as the hook.h. Then type the coded list above in this file, compile the program to generate the .dll file. That is compiling the program to generate the file, that is a .dll file. Note that this program does not contain winMain function. That is, it does not contain the main function winMain function, since the program should not execute on its own. It has been replaced by the function, or it has been executed by the function, and the function name is DLL main. So this is the theory that says that in this we have not used the winMain. Instead we have to use the function that is the DLL main, because we work on the dynamic link library. So we have to use the function DLL main instead of the winMain. This function acts as the entry point of the DLL. In simple programs we have used int main, void main. In Windows programming we have used winMain. In Linux programming we have to use the DLL main for the entry gate or for the main gate. It gets called when the DLL is loaded or unloaded. Next paragraph says, when the application loads the DLL, that is when the application loads the DLL file, the DLL main function would be called. In this function, we have merely stored the handle to the DLL that have been loaded in the memory into a global variable, H for later usage. Those functions in a DLL that can be called from outside are known as the exported functions. So the function that is so the function that is exported from the outside world, that is known as the exported functions. A DLL contains three such functions. What are the three functions? What are the three DLL functions that is available? One is the install hook function, then remove hook function, then keyboard procedure, that is a keyboard proc function. So these are the three functions that is available. To indicate to the compiler that a function in a DLL is an exported function, we have to pre-qualify it with the DECL spec DLL export. So this is the procedure how to indicate that this is an exported function. This function would be called from the second program. This second program is a normal GUI application that is carried in the, or that is application that is created in the same way that we did application in chapter 17 and 18. The handlers for the messages, that is wm create and wm destroy, are given below. Caps lock .c, then there is a h instance h, void on create, hwnd, bool, callback, pointer p. So bool, there is a bool function, then there is a callback pointer p. Pointer p function is used, then uses the load library function, that is a hook.dll, and stores the output of load library into the h. Then check the condition if h is not equals to null. That is, if it is not equals to null, uses the getProc address, that is the getProc address function is used for getting the address, that is getting the proc address, then stores the output of this getProc into the p. There are two arguments in this, one is h, one is the install hook. Then there is a pointer that is used, that is a pointer p function, that is calls the install hook function. Then there is a closing curly braces, and then there is again the closing curly braces. Then there is a void on destroy function. This is the on destroy function. Again there is a hwnd, then there is a bool callback pointer p. Again the same function is used, that is a callback pointer p, then uses the function, that is a getProc address. There are two variables in this, there is h remove hook, and the output of it, this is stored in the p. Then there is a pointer p function is called, that is calling the remove hook function. So this is the on create, that is the installing the hook. This is the on destroy, that is destroying, that is removing the hook. Then there is a free library, that is freeing the memory by using the variable, that is h. Then post quit message is used, that is like 0. So this is the explanation of this program that we have discussed in this. Oh my goodness. This is, as we know that on create and the on destroy handler should be called whenever we use the macros, whenever we use the messages, that is a wm create and the wm destroy. So these are the two messages that is used. One is the wm create message and one is the wm destroy message that arrive respectively. In on create function we have loaded the DLL containing the hook procedure. So whenever we use the on create function, we have loaded the DLL file that contains the hook procedure. To do this, we have called the load library API function. This is the function that is used, that is a load library API function. Once the DLL is loaded, we have obtained the address of the exported function, that is the install hook. So install hook is used, or install hook function is used using the getProc procedure, that is a getProc API function. The return address is stored in the P. So whenever there is a return address, that is stored in the P. P is a variable, or the P is a pointer to the install hook function. So P is a pointer that is available, or that is to the, or it is a pointer to the install hook function. Using this pointer, we have then called the install hook function. In the install hook function, we have called the API function, that is the set Windows hook X to register our hook procedure with the operating system as shown below. That is how to register the hook procedure with the operating system. That is the set Windows hook X WH keyboard hook procedure keyboard proc H instance H0. So these are the 3 or 4 steps that is available, that is uses the set Windows hook X, that is the set Windows procedure, that the output of set Windows hook X is stored in the HBK. Then there are multiple arguments, that is a WH keyboard hook proc keyboard proc H instance H0. Here the first parameter is the type of the hook that we wish to register, whereas the second parameter is the address of the hook, that is the hook procedure, that is a keyboard proc. HBK stores the handle of the hook installed, that is the HBK is the variable that is used. So from now, whenever a keyboard message is retrieved by the operating system from the system message queue, as we have seen the diagram that the operating system or the keyboard messages is retrieved by the operating system from the system message queue. The message is directly passed to the hook procedure, that is the keyboard proc function. So it is directly passed to the hook procedure, that is a keyboard proc function. Inside this function we have written code to ensure that caps lock always remains on. To begin with this, we have checked whether encode parameter is less than 0 or not. If it is so, then it is necessary to call the next hook procedure. The MSDN documentation suggests that if code is already less than 0, the hook procedure must pass the message to the call next hook x function without further processing and should return the value returned by the call next hook function, call next hook x function. Note that there can be several hook procedures installed by the different programs, therefore forming a chain of hook procedures. These hook procedures always gets a call. That means there are several hook procedures that is available. We have used the function that is the call next hook x function or the call next hook x procedure. That is in the order that is opposite to their order of installation. This means that the last hook procedure installed is the first one to be called. Now, this is the next theory of this program, that is how it will be executed. So this says if the encode parameter contains a value that is the H action, that is if the encode parameter that is used that contains this value, that is the H action value, it means that the message that was just removed from the system message is retrieved or is used whenever we store the functions. If it is so, then we have checked the previous state of the key. That is, whenever we use the H function, it means that the message that was just removed was a keyboard message. If it is the case that it is a keyboard message, then we have checked the previous state of the key before the message was sent. If the state of the key was depressed, that is the key is pressed, and that is the 38-bit of the I param is 1, then we have obtained the state code of the caps lock key by calling the getKeyState API function. That means first of all we have used the function, that is first of all we have checked whether the key is pressed or not. And if we are obtaining that key is pressed, then we have to obtain the state of the caps lock by calling a function that is a getKeyState API function. If it is off, that is if it is off, that is the 0th bit of the state variable is 0, then we have turned the caps lock by simulating a key press. For this simulation we have called the function get, that is the keyboard event function, twice. First call is for suppressing the caps lock and second is for releasing it. So there is a keyboard event that is used. One is used for pressing the caps lock and second is used for releasing the caps lock. Note that the keyboard event function creates a keyboard message from the parameters that we pass to it and post it on into the system message queue. The parameter VK capital represents the code for the caps lock key. The VK capital function is used, that is used for the caps lock key, that is it is pressed or not. Then there is a word of caution, that is a word of care, that is care has to be taken on this. When we use the keyboard event function to post the keyboard message for a simulated caps lock key press, once again our hook procedure would be called when these messages are retrieved from the message system or system message queue. But this time the caps lock would be on, so we would end up passing control to the next hook procedure through a call to the call next hook x function. So this is the function that is used, that is the call next hook x function that is used for the calling the next hook function that is used. When we close the application window, as usual the on destroy function will be called. So at last there will be a function, that is the onDestroy function, that is used for destroying the function, hook. In this handler we have obtained the address of the hook, remove hook function, exported function, and called it. In the remove hook function we have unregistered our hook procedure by calling the unhook windows hook hex API function. Note that to this function we have passed the handle to our hook. As a result, our hook procedure is now removed from the hook chain. Hereafter, the caps lock would behave normally. Having unhooked our hook procedure, the control would return to the onDestroy handler, where we have to promptly unload the DLL from the memory by calling the free library API function. So this is the function that is used, that is the free library API function for freeing the memory, or for freeing the scenario, for freeing the variable that is used. One last point about this program, that the hook.dll file should be copied into the directory of the application's exe before executing the exe file. So now let's take a break for 5 to 10 minutes, then come back, then starting with the practical approach, and in the tomorrow's class we will be starting your next topic, that is, did you press it twice? That is the next topic. So let's take a break and move to the practical approach after the break. So let's take a break first of all. So now let's come back from the break and starting with the practical approach of the C programs, that is how to do the practical approach of the C programming. So let's start with the practical approach. In the last class we have discussed about the functions, that is how to use the functions in this. How to use the arrays, functions, string functions, standard library functions, how to use. We have discussed how to do the multiplication, how to print the matrix in the last class, right? Now today the same continuation of the program, that is continuation of the matrix, that is how to print the matrix and how to display them in the same order like 1 1 2 2 and so on, right? So now let's start with the program, that is how to do the operations on the matrices. So first of all there is a header file, that is hash include stdio.h. Then again there is a hash include conio.h. Then there is a void main for the main function. That is a void main or int main, any main function. Then there is a curly braces for this one. Then there are a multiple variable declaration like int I, j, r1 for row 1, then c1. First of all I have to give the name, what is a program. So this is write a program to perform addition and subtraction of two matrices whose orders are up to, or simply this one, right? Then r1 c1, then there is a and we have defined the matrices over there, that is 10 10. This is the maximum limit. Then B again 10 10. Then uses the clear screen for clearing the screen. Then uses the printf, that is enter the order of the matrices. So first of all, the order of matrices. It is also printed in the next line. That is /n. Then there is a scanf, that is %d, %d. Then there are two variables, that is r1 and c1. Right. Then there is a printf, that is simply enter the elements of the matrices. Matrix of A, that is the first matrix, right? Then uses the for loop for printing the first matrix, that is I equals to 0. Then I is less than row 1, then I plus plus, right? Then again uses one for loop, that is j equals to 0, j is less than equals to I, or c1 not I, then j plus plus. Then again uses simply the scanf, that is for printing purpose, that is %d, then ampersand a I j. Right. Then close this one, that is closes this one. Now again the same step, that is printf enter the elements of B. So if I copy this one and print over here, if I paste over here, that is enter the elements of B, this is the same, that is the I is less than 0, j is less than 0, instead of A this is B, right? Now this is next one, in the next line it is printed, this is print in the next line, this will also print in the next line. Then again there is a printf, that is matrix multiplication or matrix addition, right? Then uses again the same loop, that is a for I is less than equals to 2 and less than equals to this one. If I copy this one and if I paste this one, the same procedure is used. Now instead of using the print scanf, I have to use the printf over here, then %d, then there is a aij, then there is a plus bij, that is aij and the bij. Then print in the next line, that is the printf, that is /n, that is for this one. So these are the two loops for addition purpose, that is for adding the value, that is a matrix addition. In the same way there is a matrix subtraction also, that is matrix subtraction, that is SUBTRACTION. Then again the same procedure, instead of a plus there is a minus. Then again go to the next line. Now then moves to the next line, get ch, then uses this one. If I compile this code, there are 5 errors. Declaration syntax missing. So this is not comma, this is this one. Now if I compile, there are 4 errors. Statement missing. This is not a comma, this is a semicolon. This is not a comma, this is a semicolon. This is not a comma, this is a semicolon. Now if I compile this code, there is only one error. This is not a comma, this is a semicolon. Now if I compile this code, there is a success. If I execute this code, enter the order. If I am saying 2 by 2, that is we have to enter only 4 elements. Suppose 2, 3, 4, 5. Enter the matrix of B. For example, 3, 4, 5, 6. The matrix addition is 5, 7, 9, 11, and the subtraction is -1, -1, -1, -1. Right? So how is that possible? Whenever we add the elements, that is 2 plus 3 is 5, the first element is added with the first element. 3 is added with the 4, that is 7. 4 is added with the 5, that is 9. 5 is added with the 6, that is 11. So there are 4 elements, 5, 7, 9, 11. And the matrix subtraction is 2 minus 3 is -1. 3 minus 4 is -1. 4 minus 5 is -1. 5 minus 6 is -1. This is the matrix addition, matrix multiplication. If I again compile this code, enter the order of matrices. That is, we have to enter the order. For example, the same, that is 2 by 2 matrices. Enter the elements. Suppose we have entered 10, 20, 30, 40. Right? Then enter the elements of B, that is 10, 20, 30, then 40. The addition is 20, 10 plus 10, 20, 20 plus 20, 30, 20 plus 20, 40, then 30 plus 30, 60, then 40 plus 40, 80. And the subtraction is 0, 0, 0, 0. Why? Because 10 minus 10 is 0, 20 minus 20 is 0, 30 minus 30 is 0, 40 minus 40 is 0. Now again compile this code. Now let's take some good values. That is, enter the elements. The same 10, 20, 30, 40. Right? Next element, that is 90, that is 20, that is 60, or we can say 10, then there is a 15. The addition is 10 plus 90 is 100. The first element is 100. Then 40, that is 20 plus 20, 40. Then 30 plus 10, 40. Then 40 plus 15, 55. And the subtraction is 10 minus 90 is minus 80. 20 minus 20 is 0. 30 minus 10 is 20. 40 minus 15 is 25. So this is the element that is printed over here. Now for safer side, if I give the percentage 5D over here, that is the 5D. Now if I compile this code, the same element, that is 2 by 2, the same 3, 4, 5, 6, this will print like this one, 4, 6, 8, 10. That is in a separate way. So this is a program that shows how to add the elements of the matrices and how to subtract the elements of the matrices. Remember one thing, whenever we perform the addition or subtraction of the matrices, the first element of one matrices is added to the first element of second matrices. In the same way, second element of first matrices is added with the second element of second matrices. That is, they are paired with each other with on the basis of the elements on which they are performing, on the basis of the elements which is using them, on which they are using them. That is the elements. So there are 4 loops. There are 2 for loops that is used over here. Right. So this program is clear to each and everyone. I discuss this program. Yes. 5D means the five spaces, single space, that is some space is given between the 4 6, so for example that means 5 space, 5 dot space. So if I give percentage 5D, that means the dots are given or spaces are given in a 5 pixel, that is 5 dots are separated or side out, and then the character will print. That means for simply giving the space we have to give the percentage 3D, 5D, 2D, n number of Ds that is available. For example, this is the program. There are two header files. There is a void main. These are the various functions that is used. That is I, J, R1, C1, A, 10, 10, B, 10, 10. So these are the variables. These are the variable that is declared. That is first one is I, then J, then R1, C1, A, 10, 10, B, 10, 10. That means four variables are declared first of all. That is I, J, R1, C1. Then there are two matrices that is declared. One is the A matrix that contains the 10 10, that is the maximum element, and then B that also contains the 10 10, that is also the maximum element. Then uses the clear screen for clearing the screen. Then yes, it is a maximum, it is the maximum value that a matrix contains. That means the maximum we can give the 10 rows and maximum we can give the 10 columns. The first part contains the rows, the second part contains the columns. Alright? No, no, no. This is the maximum limit. That means we can store. First of all, understand what is a matrix. Matrix is a collection of rows and columns, right? So if we are giving the name of the matrices as A, so the maximum limit or the maximum rows we can insert in the A matrix is the 10, and the maximum columns that we insert in the B matrices or the A matrices column is the 10. That is maximum we have to give the 10 rows and the 10 columns. Yeah, we have first of all this will ask you the order of the elements. That means you have defined the order as a 2 2. 2 2 means 2 rows 2 columns. But you can give the maximum up to 10 10, not 11 11. Yeah, 9 values. 3 into 3 is 9. Yeah, if you use 2 2, that is 2 into 2 is 4. That means 2 rows and 2 columns. There are total 4 values. Yeah, 3 rows, 3 columns. So there are total 9 elements. Count it. There are 3 rows, 3 columns. In one row, there are 3 columns. Yeah, that is multiplied. Yeah, yeah, yeah. Not addition, but multiplication. Ye yeah, there are total 16 elements. Okay. Okay, then it is asking the order of the matrices. That means what's the order? How many rows you want? How many columns do you want? That is the order of the matrices. Then store the order. That means if you are giving 2 2, the R1 contains the 2, C1 contains the 2. If you are giving 4 4, then R1 contains 4 and the C1 contains 4. That is, it defines the rows and the column that is stored in the variable, that is R1 and the C1. For example, this is my example. Yeah, tell me. Yeah, R1 is the rows and C1 is the column. These are the simply variables for the looping. Yeah, this is the next is the printf, that is enter the elements of the matrices A. First of all, we have to define the matrix A, then we have to define the matrix B. Then we have to add the values of the matrix A and B and subtract the values of the A and B. So first of all, it is printf, that is enter the matrices of A. That is first of all we have defined the order, that is how many rows, how many columns. Then we have to give the elements, how many elements are there in a matrix A. That is continued till row 1 till column 1. This is the same loop that we have discussed so many times. There are two loops, outer loop, inner loop. Inner loop terminates, then only move to the outer loop. Then the output or the this is stored in the A matrices, that is I, J, that is the A matrices. So this is used for printing the or storing the values in the matrix A, right? In the same way, this says enter the element of the matrix B. This is used for storing the elements of the matrix B. Let's start with the 0, R1, C1, 0, 0 stored in the B. So these are the two printf and the for loop that is used for storing the elements of the matrix A and elements of the matrix B. Then there is a printf, that is a matrix addition. There are again the loops that is used, that is 0, again R1, C1. Now this is used for addition. First of all, adding the elements of the A and the B. That means every element, for example first row first column element of A, that is matrix A, is added with the first row first column element of the matrix B. That means it is or it adds the corresponding element. If there is a first row second column, that is the first row second column of the A will be added to the first row second column of the matrix B. That is not that 2 1 is added with the 1 2. No, the same element, the same corresponding element is added with the matrices. For example, 1 1 of A, 1 1 of B, 2 2 of A, 2 2 of B. 2 2 means second row second column. 1 1 means first row first column. So there are so many examples of the rows and the columns. So this is for the addition. In the same way, it is used for the subtraction. Instead of using the plus, we have used the minus. So these are the two printf that is used for the addition and the subtraction, and at last there is a getch that is used for the printing the output. Now tell me, this program is clear to each and everyone? Okay. In the same way, you can multiply the elements of the matrices. So this is a full-fledged program that is used for adding addition and the subtraction of two matrices, for example A and B. Alright, so first of all we have to save this one. We have to give the matrix addition. Now if I change it to the 2 2, right, now if I execute this code, now if I give the order as a 3 3, so we have to give the values as a 9. So this is look, this is in a continue way. This is an infinite loop. Why? Because we have defined 2 2, but we are giving the as a 1 1. This is the program, that is it is not executing as a 2 2 because it is the less number and we have used the more number, that is a 3 by 3. So this is the maximum limit. We cannot go beyond the maximum limit. For example 10 10, so we are not going beyond the 10 rows and the 10 columns. Okay. So again we have to define 10 10. Now if I compile this code, Now if I enter as a 3 by 3, now 1 2 3 4 5 6 7 8 9, enter the elements of B. For example, the same elements, the addition is this one and the subtraction is this one. Addition is 2 4 6, that is 1 plus 2, sorry 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, 6 plus 6, 7 plus 7, 8 plus 8 and the 9 plus 9. And the addition is the same, 0 0 0 0 0. This is 3 by 3 matrices, that is 3 rows and 3 columns. Look, 2 4 6 8 6 8 10 12, these are the 2 rows and the 2 columns. If I give percentage n over here or slash n, you can see more precisely, that is after addition there is a slash n. Suppose 2 by 2, this is, you can see more precisely, that is 2 4 6 8 0 0 0 0. This is 2 by 2 matrices. This is the program that shows the matrix addition and the matrix multiplication. So any doubt, anyone in this program? Anyone, any doubt in this program? So that's all for today's session. In the tomorrow's class, I'm continuing with the same topic, that is, did you press it twice? That is the same continuation of the communication with the hardware, that is how to interact with the hardware. So let's stop over here only. So, and if there is any doubt, then please text the doubt and I will answer you. So thanks a lot everyone. Bye bye. Yeah, hi Larry. Are you able to hear me? Larry? Okay, so what's your doubt? Yes, yes, yes. Are you able to see my screen right now? So this is the thing you give me that okay, okay, okay. Sure. I will take this one. This is a program, I think, yeah. Mm, 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 mm. Larry, you are not able to, or I think the main concern is that you are not able to execute the program in a sequence way because it is 32-bit release. There are various drop-down menu in this. You can debug the project, you can helper.c, you can take the help. This says what is the error in this? See user Larry document collect to error return one exit status. That is, there is a error in the exit status. We have to exit the status, we have to use the status of the this one. This is the error, you cannot execute it very carefully.